Hello viewers, it's good to come your way again in another session in mathematics. Today I'll be discussing geometry, and of course geometry is that aspect of mathematics that deals with shapes. These shapes are classified as plane shapes and also as solid shapes. So on the screen you can see that geometry is the aspect of mathematics which deals with the study of different shapes. These shapes of course can be plane shapes such as triangles, rectangles and squares and etc. of course. Now when a shape is a plane shape, all the lines, all the edges, all the sides of that shape can be represented on the plane. Alright, the plane system of x and y axis. And of course when a shape is a solid shape like the cubes, like the cuboids, the cylinder, the sphere and the rest, all the sides, all the angles, all the edges of such a shape cannot be represented on the plane surface. So that is why we have the plane shapes, triangles, squares, rectangles, circles and of course trapezium and the rest. Those are regarded as plane shapes, and of course the solid shapes are shapes where all the sides cannot be represented on the plane surface. Alright, now when we talk about these shapes of course have the sides and also the corresponding angles. Now whenever two sides meet, an angle is formed. So an angle is the meeting point of two lines. Alright, now these two lines are sides of a particular shape, and when they meet together some way, somehow, we call them angles. And of course in geometry, most importantly, we discuss a lot about angles and what we are trying to solve, because when you are solving a typical mathematical problem as far as geometry is concerned, you are trying to find the angle at a point given a particular shape, and also the necessary theorems that you might need to use to be able to evaluate that. So as far as geometry is concerned, we deal majorly with what we call angles, and on the screen you can see that there are various ways we can classify angles depending on their size. Alright, now on the screen you can see an angle called the acute angle. This is an angle less than 90 degrees, like 30 degrees, like 40 degrees, like 50 degrees. All these are examples of acute angle. So an angle is acute if the value is less than 90 degrees. An angle is called a right angle if the value is equal to 90 degrees. So if an angle is to be given as 90 degrees, then that guy is called a right angle. The next you can see on the screen is what we call the obtuse angle. Of course, obtuse angle is an angle more than 90 degrees but less than 180 degrees. It's an angle that is more than 90 degrees, like 120 degrees, like 150 degrees, like 160 degrees. All these are obtuse angles. The values are more than 90 degrees but they are less than 180 degrees. And of course when an angle is more than 180 degrees but less than 360 degrees, such angle is now called the reflex angle. More than 180 but less than 360. We have complementary angles too, as sum of angles that will add up to give you 90 degrees. So two or more angles are said to be complementary if they add up to 90 degrees. 40 and 50 degrees are complementary angles because 50 plus 40 will give you 90 degrees. 60 and 30 are complementary angles, and of course 45 and also another 45 degrees are also called complementary angles because they will always add up to give you 90 degrees. And of course angles are called supplementary angles if they add up to give you 180 degrees. So if we have two or more angles, and the sum of all these angles will give us 180 degrees, we call them supplementary angles. If they add up to 90 degrees, we call them complementary angles. If it's more than 180, less than 360, we call it a reflex angle. If it is more than 90 but less than 180, it's called an obtuse angle. If it is equal to 90 degrees itself, it's called a right angle, and of course if it is less than 90 degrees, it's called the acute angle. Alright, the first part of geometry we are going to look at in this session is to establish angles that are formed by parallel lines, and of course we try to solve some problems after identifying the facts about these angles. Now when we have two parallel lines, of course you know what a parallel line is. If we have two parallel lines, these are lines that will never get to meet. They travel till infinity, they will never meet. Alright, now if we have two parallel lines like I'm about to draw now, I'm going to show you how some of these things can actually be formed. Some of these angles can be formed as far as parallel lines are concerned. And on your screen you can see that we are going to have angles called complementary angles. We are going to have angles called alternate angles. We are going to have angles called corresponding angles, and of course we are going to have vertically opposite angles. So let's see how this is done. Okay, we have two parallel lines, as you can see on your screen. I have a parallel line and I have a parallel line here. This line is parallel to this one. If I draw another line, this is now called a transversal line. I draw another line to intercept these two parallel lines. Now on this side here I can have an angle formed as A. On this side I can have an angle formed as B. Over here I can have angle C. Over here I can have angle D. So at that point 4 angles can be formed, A, B, C, D. Don't forget, angles are formed whenever 2 lines meet. So at each point in time you can see what I've drawn there. You notice that there's actually a meeting point. Now on this other guy here down here I can also have an angle here E. Here I can have an angle here F. Here I can have an angle G. And here of course I can have an angle called H. Now we can begin to state some properties as far as these angles are concerned. Now on the screen I showed you earlier, you can see angles formed by parallel lines. There's what we call corresponding angles. Corresponding angles are equal, I will identify. There's what we call alternate angles, and they are equal mathematically. There's what we call vertically opposite angles, and they are equal mathematically. And there's also what we call interior opposite angles, and these ones are supplementary. These are the 4 theorems that we are going to look at as far as angles formed by parallel lines are concerned. And of course we will be using this to solve some mathematical problems at the end of the day. Now we get back to this screen. We have A, B, C and D. Over here we also have E, F, G and H. These are the angles that are being formed as far as these 2 parallel lines are concerned with the transversal line that is bisecting them. Alright, the first thing we are going to establish is that corresponding angles are equal. Corresponding angles are equal. So from this diagram we have here, I want to show you those angles that are corresponding. Now notice where we have angle A on this side of that transversal line. Notice where we have angle E on this other side of that same transversal line. Both A and E are on the left hand side of the transversal line. So those angles are corresponding. So A is equals to E mathematically. If A is a value 40 degrees, that means E is also a value 40 degrees. The reason there is that they are corresponding angles. If you look at your right hand side, you have angle B. You look at the right hand side of the second parallel line, you have angle F. So we can also say that B is equals to F. The reason is that they are corresponding angles. The same thing on the right hand side of the first parallel line is the same thing on the right hand side of the second parallel line. So those angles are said to be corresponding, and mathematically they are equal. So if that angle B there was 140 degrees, that means angle F is also 140 degrees. Now if you see under this first parallel line, the first angle on the left hand side, which is C, that is under the line, and you also come to the second guy here, which is the second parallel line L2. Let's call this L2, call the first parallel line L1. So if you look at L2, which is the second straight line, and the angle that is just under that is G. Okay, so we can also say that this C that is under the first parallel line is also equals to this G that is under the second parallel line. So here we can establish that C is equals to G. And finally the last guy here on the right hand side under of L1, which is the first line, we have an angle D, and what we also have here under this second parallel line is H. So we can also say that H is equals to D. These are called corresponding angles in maths, and they are equal. So if you see a diagram in your exams and 2 parallel lines are drawn, a line is drawn that is transversal, and maybe one of those angles are given and you are asked to find something else, you notice that that particular angle shares the same as the other one you are asked to find, the same position with respect to that parallel line. Okay, then you can call it corresponding angle. So from what we have drawn here, A is equals to E, B is equals to F, C is equals to G, and of course D is equals to H. These angles are called corresponding angles, and they are equal. We'll be using this theorem to solve question at the end of the day. Now the second thing you can see is that alternate angles are equal. So from this diagram I have drawn here, let's see what we mean by alternate angles. But before then, I would love to point out to you that if you have something like a Z symbol, letter Z, you have something like this, as you can see on the screen, like a Z symbol. Now if you have an angle here and you have an angle here, those are called alternate angles. When you have something like a Z, what is here and what is here are called alternate angles, like a Z. Okay, now if you also draw it in the reverse direction, maybe like this, what is here and what is here are also called alternate angles, and mathematically they are equal, they share the same value. All right, so we get back to this shape that I drew earlier. If I pick something like a Z symbol here, if I pick something like a Z symbol here, look at this Z here, look at this Z I have drawn there. Now you notice that what is here is C and what is here is F. So I'll say that C is equals to F. Reason is because they are alternate angles. And if I draw it in the reverse direction like this, draw it in this reverse direction, what is here called D and what is here called E are also equal. So D is also equals to E from this diagram. D is equals to E. This is what we call alternate angles, like a Z. What is here and what is here are equal. If you draw it this other way, what is here and what is here are equal. We call them alternate angles. All right, to wrap it up, vertically opposite angles are equal. In mathematics, that's the third guy. Vertically opposite angles are equal. Now if you look at this diagram I drew earlier, A is vertically opposite to D. Vertically, that's what is just direct opposite of the other one. So A and D are vertically opposite, so A is equals to D. Now C and B, these two guys are also vertically opposite, so C is equals to B. On this other side, E and H, E is equals to H, and also G and F, G is equals to F. G is equals to F. We call these vertically opposite angles, and they are equal in math. Corresponding angles are equal, alternate angles are equal, and vertically opposite angles are also equal. That's the angle that is just direct opposite of the other one. We call them vertically opposite angles, and they are equal. And finally, we have that interior angles are supplementary. Interior opposite angles are supplementary. If you look at this diagram I have drawn, now in geometry, if you form an angle outside the shape, these angles are called exterior angles. But when you form angles within the shape, inside, these angles are called interior angles. So what we have drawn here, you can notice that in between these two parallel lines, okay, we have C and D, and we also have E and F. So C, D, E and F are called interior angles. Then A, B, G and H outside, these two parallel lines are called exterior angles. Okay, now the theorem is that interior opposite angles are are supplementary. So you have E and C, these two guys are opposite each other. Look at it, these two guys are opposite and both of them are interior. So in mathematics we have that E plus C is equals to 180 degrees. And also on the right hand side, you can also see these two guys, F and D. Now D plus F is also equals to 180. Don't forget, I told you that supplementary angles are angles that add up to 180. All right, so the theorem is that interior opposite angles are supplementary. So E and F, you know, are supplementary angles, they will add up to 180. And also D and F are also supplementary angles, they will add up to 180. Ladies and gentlemen, these are the properties of angles formed by two parallel lines when a transversal line is drawn. And of course, I have identified corresponding angles, I've identified alternate angles, I've identified interior opposite angles being supplementary, and of course I've also identified corresponding angles being equal too. Don't go anywhere. In the next video, I'll be showing you how we can use these theorems to solve some mathematical exercises. See you there.